So today in 8.7, the law of cosines is what we're talking about. And in the law of cosines, we're going to think about something first, and then we're going to talk about what the actual formula is, and then we're just going to do a bunch of examples. So in this first think about it thing, it says that we have two hot air balloons approaching a landing field. One's 12 meters from the, 12 miles probably actually, from the landing point, and the other is 17 miles from the landing point, and the angle between them is 70 degrees. How far apart are these two balloons? So if I were to draw a picture of what this looks like, here is one balloon that's 12 miles away from a landing point. Maybe I call that L. And then the other balloon is 17 miles away. The angle in between is 70 degrees. And you're trying to figure out how far apart those two balloons are. So here's one balloon, and here's the other balloon. And the big idea here is when we use the law of cosines, you want to make sure that you have two sides and the angle in between. So yesterday we talked about the law of sines, and I told you that we use the law of sines when we have two angles and a side. Today we're talking about the law of cosines, and you will use the law of cosines when you have two sides and the angle in between those two sides. That's really important. The law of cosines says the following: c squared equals a squared plus b squared, which looks like the Pythagorean theorem. Very good, Grant. Minus 2 times a times b times the cosine of angle C. If, on this dark blue case here, this is when I'm looking for a side. So off to the side here, this is when you're looking for a side. In the next part, what I'm going to write down is the same exact rule, but with that dark blue equation rearranged to find the C value. You might recall yesterday that we talked about when you're looking for an angle, you have to use the second button on your calculator because you're doing the inverse. Do you guys remember that? Yes. So in this case, the same thing is true. And if you wanted to memorize another equation, which I don't particularly like doing, but if you wanted to, and you rearrange this dark blue equation, what you would see is that angle C will be equal to the cosine inverse of, and then it's a big long fraction, and it'll be a squared plus b squared minus the c squared all over 2 times a times b. Now when I do my problems with you in my examples, I don't really have this orange equation memorized. What I do is I only work with the blue equation, and in the context of my problem, I rearrange it to solve the problem. Down below, we already actually talked about this part. We talked about the reason that you will use the law of cosine is when you're given two sides and the included angle, which means the angle in between those two sides. So the example up above that we talked about it in the think about it with the two balloons and finding how far apart they were, that was the example of when you would use the law of cosines. In our first example down below, we see two sides, 11 and 18, and then we see the missing side that we're looking for. And since that's the missing side that we're looking for, I'm going to call that side C. So here's my C, because our formula talked about how you find the C squared. So when I start out, I always write the equation first because it helps me remember where to plug junk in. So the equation was C squared equals A squared plus B squared minus 2AB cosine of angle C. Since I don't know what the C is, what I'm going to do is I'm going to now write that as c squared equals, and notice how the other two sides are not labeled a and b. It actually does not matter which one they are. So whatever I see first, which I read from left to right, so I'm going to pick the 11 as the a. I'm going to go with 11 squared plus 18 squared minus 2 times 11 times 18 times the cosine of the angle in between them, which was 56 degrees. And so as we look at where these things are coming from, the 11, which we're calling the A, came from one side of the triangle. The 18, which we're calling the B, came from the other side of the triangle. And the C, which is the side we're looking for, came from the side that we're looking for, or the last side of the triangle. So here's my 11 again, and here's my 18. So now all I need to do is I need to go to my calculator and type all that in. So I go to my calculator, and I go with 11 squared plus 18 squared. Oh my goodness, I hate this calculator. Sorry, I'm not used to using this. 11 squared plus, oh my goodness, sorry, 18 squared minus 2 times 11 times 18 times the cosine of what? 56. Parentheses, boom. I get 223.56. So I know that c squared equals 223.56. Am I looking for c squared? No. I'm looking for c. So how do I get my c?
Square rooted.
Square root it. So I just square root that. And then that means that my c will be equal to whatever the square root of that number is. So back to my calculator, I take the square root of 223.56, and I get 14.95. And basically this is all there is to the law of cosines. Plug in the numbers, at the very end take the square root. So do you notice how in this problem they label the sides A, B, and C, or the angles A, B, and C, or whatever? Well, that kind of messes me up because everything's in relationship to C, right? So if you want to, one of the things that you could do is you could just go, nope, I'm going to call that C, because that's the angle I'm looking for. Which means then, of course, this can't be called C anymore, so I'm going to call that A. So if you want to, you can rename the vertices in order to help you remember what you're supposed to do. The equation is still the same. The equation is c squared equals a squared plus b squared minus 2ab, cosine of c. But this time, when you put things in, here's what you'll notice. You'll notice that you get 11 squared, because that's what's across from the angle c, equals the a squared plus the b squared minus 2 times the a times the b times the cosine, and I don't know the angle c. So all of these things are coming from somewhere. The number 4 is here and here. The number 13 is here and here. And the number 11, which was the C, is right there. So here are their respective places, in case you were wondering. And we don't know angle C, and that's what we're looking for. Now, there was an equation that I wrote down secondly that talked about what happens when you're looking for that angle C, but I don't remember that equation very well. So all I do is I rearrange this equation. So this is how it works when you rearrange. First of all, you notice that the 4 squared and the 13 squared are on the right-hand side of the equation with the unknown thing that I'm looking for. So we're going to take the 4 squared and the 13 squared and move them to the right, or to the left, pardon me. When I move them to the left, instead of being positives, they'll become negatives. So I get 11 squared minus 4 squared minus 13 squared equals the negative 2 times 4 times 13 times the cosine of the angle I'm looking for. But then I still notice there's something over there with that cosine. So I want to get rid of the negative 2, the 4, and the 13. In order to get rid of them, since there's all multiply there, I divide everything by those 3 things on both sides. So I divide by negative 2, 4, and 13. And what ends up happening then is the things that are on the right-hand side, these 2, 4, and 13 things, go away. And so I see that my cosine of my angle is equal to all this mumbo-jumbo. But I don't want that. I don't want the cosine of C. I want to know what C is. So when I start simplifying this thing off to the left here, I'm going to take and divide all the stuff I see on the left-hand side to get a number first. And then I'm going to write that down as whatever the cosine of C is. So I know that the cosine of my angle C is equal to something. So let's do that on a calculator right now. You're going to have to help me remember this because my screen disappears. So I've got 11 squared and it was minus 4 squared minus 13 squared. And already I'm going to make an error here. Can you guys figure out what my error is? Yes, who said that? Good job, Nicole. I need parentheses. So let me go back here. This all needs to be in parentheses. What was the first number? 11? Like that? Divided by parentheses. And what was on the bottom? Negative 2 times 4, thank you, times 13. What the craziness? What did I do wrong? Okay. What's happening here? It is not liking that parentheses. Okay, let's try this.